Hello, everyone. I'm William Johnson, and today I'm going to be walking us through a one-page infographic on cloud-based software. I'm going to be going over problem formulation, a brief literature search and overview, a critical analysis, and evaluation, and highlight what I found to be most interesting. In our problem formulation, we define three deployment models: public, private, and hybrid, and the three service layers: infrastructure as a service, platform as a service, and software as a service. On the other hand, to stay focused, we're going to intentionally exclude low-level and vendor-specific code, keeping our scope to high-level architectural decisions. I'm going to be going over a literature search, going through the highlights or the points of three different studies. This first one from 2010 demonstrated how elasticity, which is a cloud platform's ability to scale, and multi-tenancy, which is basically, allowing multiple tenants or clients to use this cloud system, can reduce resource costs up to 40%. The second one walked through a real-world migration effort of a legacy enterprise application to Amazon's Elastic Compute Cloud, otherwise known as EC2. They found that re-architecture time can take up to 20 to 30% of the total migration time, which ends up being a lot. Lastly, the study from 2020 showed a type of iterative pilot, evaluate, expand rollout method, cut 30% of security incidents in, and also kept cloud budgets on track. So this is the critical analysis. Moving to cloud shifts big upfront hardware costs into ongoing pay-as-you-go fees. This is great for flexibility, but surprise strikes can hurt budgets. So next, I think it's important to go over the three deployment types that we went over before. We have it's a bit of a hierarchy. Starting at the bottom, we have infrastructure as a service, which is a cloud computing model where a provider delivers essential computing resources like servers, storage, and networking on demand, and on a pay-as-you-go basis, providing raw computing power, storage, and networking. All the while, you get to manage the OS and middleware. Platform as a service is a little more high level and offers a pre-configured environment handling OS and runtime. You can just go ahead and deploy your code. Lastly, software as a service, which is the most high level of the bunch, delivers fully managed apps like email or CRM, where you can just click and go. Next is some of the critical analysis. So here we find that switching to cloud infrastructure does wonders for efficiency by replacing a lot of the hardware expenditures with flexible pay-as-you-go usage-based charging. Unfortunately, this can also result in unanticipated costs and spikes as well as outages. The major carriers of cloud services do assure robust uptime, but unfortunately, region-wide outages do continue to occur, which underscores the necessity of multi-region failover and resilience planning. So we want to make sure that we have region-wide backups for these cloud services because a lot of enterprise applications rely on these 24/7. All right. So I believe that for a successful cloud implementation, a hybrid cloud strategy, keeping sensitive workloads on a private infrastructure while data bursts over to public clouds. And we can see here that cloud services are still becoming increasingly popular and will be a part of computing and development for the next few years to come. Thank you for listening and have a good day.